The Moxon rectangle, originally developed by Moxon G6 X-ray November and heavily popularized by LB Sebic W4RNL, is a brilliant piece of antenna engineering. In simple terms, it takes a standard two-element Yagi, a driven element and a reflector, and folds the ends backward towards each other. This simple geometric change creates capacitive coupling between the folded tips, completely altering the antenna's electrical characteristics. Whether you are building a directional wire antenna for the HF bands or putting together a handheld array for LEO satellites, the Moxon solves several design headaches simultaneously. Compact footprint. By folding the elements, the turning radius and overall width are reduced by roughly 30% compared to a full-size Yagi. Direct 50 ohm match. Traditional Yagis often have very low feed point impedance, around 15 to 25 ohms, requiring a matching network like a gamma or hairpin match. A properly designed Moxon naturally sits near 50 ohms, meaning you can connect your coax directly to the driven element, usually with just a simple 1:1 current choke. Massive front-to-back ratio. The Moxon is famous for having a deep null off the back. It can easily achieve a front-to-back ratio of 25 to 30 dB, making it spectacular for rejecting rare-weight QRM, that is interference. Broad forward lobe. It has a very wide, forgiving forward beam width. This makes it particularly excellent for handheld satellite tracking, as you don't have to keep the antenna pointed with absolute pinpoint precision to maintain the downlink. A Moxon is defined by 5 critical dimensions. Because the tips of elements couple capacitively, getting the gap and the element lengths exactly right is crucial to making the antenna resonate and maintain its 50 ohm match. 1. A. Total width, typically 0.36 wavelengths. 2. B. Driven tail, the folded back portion of the driven element. C. The gap, the space between the driven element tip and the reflector tip. This is the most critical dimension for tuning the SWR. D. Reflector tail, the folded back portion of the reflector. E. Total depth, the distance from the driven element to the reflector, usually around 0.13 wavelengths. Here is a rough AI generated visualization corresponding to the description given earlier for a 145.80 MHz wire antenna, that is with a wire width of 2 mm only, not the usual aluminum pipe. The gap dimension C is highly sensitive to nearby materials. If you use plastic or CPVC insulators to physically bridge the gap between the tips, the dielectric constant of that material will lower the resonant frequency slightly. Always cut the tails slightly long so you can trim them for perfect resonance once assembled.